A planet that survived the death of its star. A look into the future of the Solar System. Thousands of light-years away, in the constellation of Sagittarius, astronomers have found a planetary system consisting of a Jupiter-like planet orbiting a white dwarf. According to scientists, this system shows what our solar system will look like in a few billion years, when the Sun comes to an end. How will the solar system end? Scientists have been wondering about this issue for years. We know that stars like the Sun, once they have used up all the hydrogen in their core, swell, slowly losing their outer layers until only the stellar core remains. Such remnants of a star are called white dwarfs. However, this process is devastating for the planets orbiting the star. When Sun-like stars run out of fuel, they swell, increasing in size hundreds or even thousands of times. They then become a red giant that absorbs nearby planets. This is what the distant future of our solar system will look like. Scientists are asking themselves which planets can survive the death of the Sun. One way to look for answers is to look at the fate of other similar planetary systems. However, finding similar systems where the star has already died has proven difficult. The weak radiation of white dwarfs does not make the task easier. But scientists managed to spot an exoplanet that survived the stellar transformation. In fact, of the more than 4,500 exoplanets currently known, only a handful have been found around white dwarfs. The location of these planets suggests that they arrived in their current location after the stars died. One such planet was found near the center of the Milky Way, 6,500 light-years away in the constellation of Sagittarius. This is reported by an international team of astronomers in the journal Nature. The planet orbits a white dwarf that has a mass about 53% that of our Sun. The planet itself has a mass of about 1.4 times that of Jupiter and is located 420 million kilometers from the remnants of its host star. Compared to the Solar System, this would be about the distance between the Sun and the dwarf planet Ceres, the largest object in the asteroid belt between the orbits of Mars and Jupiter. This confirms that planets orbiting at a sufficiently large distance can continue to exist after their star dies, says Joshua Blackman of the University of Tasmania in Australia, lead author of the study. Given that this system is the equivalent of our solar system, this suggests that Jupiter and Saturn may survive the phase of the Sun's transformation into a red giant when it runs out of nuclear fuel. He adds, Earth's future may not be so rosy because it is much closer to the Sun, says co-author David Bennett from the University of Maryland and NASA Goddard Space Flight Center. If humanity could move to the moons of Jupiter or Saturn before the Sun burned the Earth during its transformation into a red supergiant, we would still remain in orbit around the Sun. Even though we could not rely on its heat, he points out. The planet was discovered using a technique called gravitational microlensing. The phenomenon of microlensing occurs when light from a distant source is diffracted by a closer object called a lens. The mass of the lens curves the space around it, which causes the light rays to bend, resulting in the brightening of the source. In other words, gravitational microlensing occurs when the object's gravity bends and amplifies light from more distant stars when the radiation source, the lensing object and the observer on Earth are in alignment. In 2010, such a phenomenon occurred when one star passed directly in front of another star. From the perspective of an observer from Earth, of course, the gravity of the closer object, like a magnifying glass, made the distant star appear hundreds of times brighter for a brief moment. In this way, the presence of a large gas planet was revealed. However, scientists wanted to check what the lensing objects were. Scientists have discovered that the star's light is not bright enough to be an ordinary main sequence star. The data also ruled out the possibility of a brown dwarf there. We also managed to exclude the possibility of the existence of a neutron star and a black hole in the observed system. This means that the found planet orbits a dead star, a white dwarf, says co-author of the publication Jean-Philippe Bewley from the University of Tasmania. Our research offers insight into what our solar system will look like after Earth disappears, he adds. When the Sun turns into a red giant, Mercury and Venus will be destroyed. Earth and Mars also have little chance of survival, as it is estimated that the radius of the Sun-turned red giant will reach Earth's orbit. However, new observations indicate that Jupiter and other planets may avoid disaster. Jupiter and its moons will survive. We weren't sure about this before. Our discovery suggests that Jupiter may succeed, notes Dimitri Veras from the University of Warwick.